All right, so now let's go through and answer the questions that it asks you on the little sheet inside the bubbles, right? So the first question is, what time is he in the air for B, right? And the time that he's in the air is, yeah, go for it. The time that he's in the air is just this answer right here. 1.142, yes? Can we be silent? Thank you. Okay, and then C is final vertical velocity of impact. Well, this is the vertical velocity, this is the horizontal velocity, yeah? But this is the vertical, so you would say this is C. The answer to C is that one, this is the answer to B, right? How far from the base of the cliff does he hit the water? Well, that's a horizontal distance, right? That's this guy here. Right, so that distance is this one. That's the answer to D, is this one, right? And then E says, draw a picture of his velocity of impact, turn it into an angle, magnitude, velocity with a vector. Find the angle with the horizontal and label both the angle and the magnitude. Holy cow. Okay, so when he hits the water, he's doing this. He's moving over. He's got the same velocity that he had the whole time he was in the air, right? He's gained this much vertical velocity, and so he's moving both over and down. So take this velocity vector, draw it up here, right? Over 9.2, down 11.2. Notice I'm making the 11.2 longer. Therefore, this angle right here has to be bigger than 45. If I get some angle like 23, I know that's wrong, okay? So now we just need to find the angle and the magnitude. That angle there is tan minus 1 of the opposite side over the adjacent side, right? That's what it always is. So 11.2 over 9.2. So second tan, 11.2 divided by 9.2. That's 50.599 degrees. Right? Or 50.6 degrees. Okay? And then the magnitude right here, this is our magnitude. The hypotenuse is the magnitude. And that's going to equal I'm trying to be polite. So that's going to be the magnitude of 11.2 squared plus 9.2 squared. Okay, so let's go square root 9.2 squared plus 11.2 squared. Okay, 14.49 meters per second, right? Ta-da. Okay, so we've now labeled the picture. That's what should go in E, right? And a real common student mistake is to, like, when I say draw a triangle, they draw the triangle with like the displacements, right? I tend not to do that. I tend to just say how far over is he, how far down is he, okay? But velocities are useful to draw as like a vector like that, because this is the direction it's going. That's where they're going right then, okay? And then what is the speed? When you say what is the speed, what's the speed? Well, there's several things that could be the speed. The 9.2 could be, the 11.2 could be, or the 14.49. Which one's sort of the overall speed? The 14.49. So this is the speed, right? Speed is the magnitude of the velocity vector. Okay? So that's a basic Cliff problem, okay? Let's flip it over and let's look at let's put the last varsity. It's kind of a fun one. Okay, that's going to solve differently. So let's set up the last varsity question and see if we can answer that one. Okay, the last one says, what is Red Elk's position? How far over? How far up? When he's covered 8 meters of horizontal distance. So we know he's going to land here at 10.514 meters, right? If we don't round anything. So when he's covered 8 meters, let's imagine that there's a wall there. You know, he thinks that there's water, but there's really like this invisible wall or something, right? And he's just going to go boom, against the wall or something like that, right? Okay. So we want to know when he's gone 8 meters this way, okay, what is his, how far down is he? We know he's going to be 8 meters over, but how far down from the edge of the cliff is he? So what's this distance here, right? And then how fast is he going sideways? How fast is he going down at that instant? Okay? And you might say, who cares? I care. Okay? So let's try that one.